This is Algebra 1, Lesson 5A, and it's about sets. Have you heard that word before? A set? Where have you heard that? Well, the first thing I think of if somebody mentions a set is I think about Legos. When you buy a Lego set, everything that you need to make that creation is in that box. Or maybe there's a train set or a chemistry set. Everything you need to be able to make something or see a reaction. A tea set, everything you need for the tea party. A cookware set, maybe it's a golf set or a camping set. Maybe it's a TV set. We've heard that. A lot of people just say TV, but I know I used to hear people say the TV set a lot. Everything that's there that you need to see the picture and hear the audio. And then we've heard of movie sets. So a set is usually a collection of things. And in math, when you talk about sets, it's the same thing. And we have a way to describe it and a way to note it. So we have a well-defined collection of numbers here. The numbers in this set are just 1, 2, 3, 4, and 5. That's it. There's no dot, dot, dot. There's no and continue on. It's just those numbers. So maybe I would give you some sort of problem, and I told you that you had to use numbers from that set. So you could only use those numbers. Okay, we could write it, we could name it and call it set A, and we would use these little bracket things. I'll draw this for you. I think it's kind of cool to do it. You do like a backwards C, or actually that's a forward C, isn't it? I was thinking backwards. So you do a C, and then kind of like the top of a triangle, or a less than symbol, and then another C. And if you do the other side, now is your backwards C, and then a greater than symbol, and then a backwards C. Okay, if you want to draw those, because you'll have to be drawing them in your homework. So that's the brace or the set notation. So this would be set A contains 1, 2, 3, 4, and 5. Now, if I said set A contains the counting numbers 1 through 5 inclusive, that would be the same thing. This one and this one, these are the same, okay? Counting numbers, we had a Venn diagram in a previous video where we talked about the counting numbers. You start at 1 and you go on up. So it's saying, I want you to use the counting numbers, but I only want you to do 1 through 5. And when they say inclusive, that means the endpoints like 1 and 5. Because I could say that I just want 1 through 5, and there would be a way to note it if you just want the numbers in between it, and we'll get to that later. So inclusive means we're including the endpoints, okay? All right, we also could say, or we could talk about the natural numbers. If we wanted a set that was all of the natural numbers, what would we do? Well, we know that it starts with 1. There's nothing before 1. And we would do a few just to show that that's 1, 2, 3. The book even goes up to 4, 5. And then they put a dot, 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 because we can't list all of the natural numbers. So the ellipses, the dot, 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 just means that it keeps on going. What if we wanted to include 0 in that set? Okay, if we put a 0 in there, that would not be the set of natural numbers anymore. And we didn't learn about this set. I briefly mentioned it in the other video, but this set is called whole numbers. So whole numbers are just the natural numbers and then including 0. What if we included in the set, if we included the opposite of every member of the set of natural numbers? So now we talked about opposites in a previous video. The opposite of 2 is -2. The opposite of 3 is -3. The opposite of -1 is +1, right? It's going to be on the opposite side of 0 on the number line, same distance apart. What if we included the opposite of every member of the set of natural numbers? So here's our natural numbers, okay? And then we kind of made it whole in the last set, so we included 0. What if we also included all the opposites of the naturals? So the opposite of 1 is -1, opposite of 2 is -2, opposite of 3 is -3. Well, that set would be called the set of integers. That's also on the Venn diagram that we talked about the other day. So here's another set of numbers that we can talk about. And so I redid the Venn diagram here so we can kind of look back at what we talked about the other day. We know the natural numbers are 1, 2, 3, and it keeps on going. We know whole numbers include the natural numbers because the natural number circle is inside of the whole number circle. So whole numbers include all of the natural numbers, but whole numbers also includes 0. But 0 is not a natural number, so it can't be inside the natural number circle. Integers include all the natural numbers, whole numbers, which includes the 0, and all of the opposites of the natural numbers. So we would say it's something like ... -3, -2, -1, and then you pick up 0, and then you pick up the natural numbers 1, 2, 3, and so on. We'll get to rational numbers later. We also talked about reals, and that's this whole set. All of these sets are reals. When we talked about pi, we briefly mentioned irrational numbers, numbers that don't repeat or don't terminate. So we could put pi over here in the irrational set. We'll talk about more about that later. And then we'll be headed to absolute value in the next video.